This is Lesson 2-8 from the Algebra Readiness textbook. Pause the video and work on your study guide problems in your notes packet, and press continue when you are ready to compare your answers to mine. The first problem was -11c equals 33. Your job was to use the inverse operation and divide both sides by -11. Make sure you checked your work. The next problem, our variable k is being divided by 11. So your job is to use the inverse of division and multiply both sides by 11. In the last example, you needed to translate the word phrase into an equation. Then you use the inverse operation and divide both sides by 13 to get h equals 8. And again, always check your work. Today's learning target is to be able to graph inequalities on a number line. An inequality, let's put this definition in your notes, is a mathematical sentence that has an inequality sign. So far, we've dealt with equations, and equations have an equal sign. So these will have an inequality sign. Let's review what each inequality sign means. The first inequality sign that we see right here is the less than or equal to. I think of these signs similar to in English when you have a compound word. You have dog, house, which is dog plus house is dog house. Here I have a less than sign plus an equal to sign, and I get less than or equal to. The next one is a greater than or equal to sign. Now, let's talk about the graphs of these two. Here we go. Okay, which means that it's either greater than or equal to the given number. So the graphs of these two are similar. When you graph these, you graph them on a number line. So let's draw a number line for each of them. Now, to make this simple, we're just going to put numbers on our number line. There will always be a given number. So if I say that a value is less than or equal to 1, I start by putting a circle at 1, and then I decide, should I fill in the circle or not? Well, you fill in the circle if it has the equal to. So I'm going to fill that in, because 1 is less than or equal to 1. Then I show with an arrow the direction where all numbers less than or equal to the given number are located. So the numbers that are less than or equal to 1 are located to the left. On the other hand, if I asked you to graph the numbers that were greater than or equal to 1, I again would put a circle at 1. That's my starting number. I fill in the circle because 1 is greater than or equal to 1. And where are the rest of the numbers that are greater than or equal to the number? Well, numbers greater than 1 are to the right. So that's what the graph would look like. The next ones you're familiar with already. This sign right here is my less than sign. And this sign is my greater than sign. So what would that look like on a graph? If I was going to graph numbers, and we'll just go back with using 1 like we did up in the first examples. Okay, so let's say I wanted to graph numbers that were less than 1. Well, I would put a circle at 1, but this time 1 is not less than 1. So 1 is not one of those solutions. So I would then only leave it open, leave it an open circle, don't fill it in, and then draw my arrow in the direction of the numbers that are all smaller than 1. If I was drawing numbers or graphing numbers that were greater than 1, I would put a circle at 1, but 1 is not greater than 1, 1 is equal to 1. So I would not fill in that circle. Then I would draw an arrow to indicate where the numbers on the number line that are greater than 1 are located, and that is going to the right. I'm realizing that I did not write x is less than or equal to 1, x is greater than or equal to 1 up here. Any number that makes the inequality true is known as the solution to the inequality. I'm guessing you're going to need to pause the video here to get all of these notes down. Then press continue. All right, we're going to start by graphing inequalities on a number line. So first we're going to write the inequality, then we'll show those numbers on the graph. Let's say you went to an amusement park. Do you see that on this sign it says you must be at least 48 inches tall in order to go on this particular ride? So the first thing that you need to do is define, I'm going to use h as my height. So my height needs to be at least. Well, what does the word at least mean to you? The best way to figure out if that is a less than or equal to, greater than or equal to sign is to start giving yourself some scenarios close to 48 and seeing which ones would allow you to do or participate in the ride. So if you have to be at least 48 inches tall, if I'm 47 inches tall, can I ride the ride? No. So that means less than is not the number, or is not the symbol. Can I ride the ride if I am 49 inches tall? Yes, I can. So that would mean that all heights greater than 48 inches can ride the ride. However, what about exactly 48 inches? If I was exactly 48 inches, would they allow me to go on the ride? Yes, and the answer is yes. That means that I need to include the equal to. So now I've written my inequality. Heights greater than or equal to 48 inches are allowed to go on the ride. Now I need to graph those inequalities on a number line. When you're graphing an inequality, I do not expect you to write 48 tick marks on your number line. That's crazy. How about we agree that you have to include two numbers? One of the numbers must be 0, and the other number is whatever this number is. So in this case, my number is 48. Make sure you put a mark at 0, and I'm not super fussy about 48 and the location of that tick mark, as long as it's on the correct side of 0. We know that 48 is to the right of 0, so it's important that you put it to the right of 0. Now, the first thing you're going to do is put a circle at your 48. Then I need to ask myself, is 48 a solution to that inequality? Is 48 greater than or equal to 48? And the answer is yes. And it will always be yes as long as there is that equal to at the bottom. Now, where are numbers that are greater than or equal to 48? Well, numbers greater than 48 are always to the right. And so I have now graphed the inequality. So here is writing the inequality, and here is the graph of the inequality. Having the circle filled in or not is important, and the direction of the arrow is also important. Also note that my arrow is coming out of the circle. Do you see that? It needs to be attached. Do not have that separated from your starting circle. All right, so we've done the first example. Lots of you have gone, let's try another one. Lots of you have gone out to a restaurant, and you're getting to the age where some of you hate eating off of the kids' menu. So here's a kids' menu to a restaurant. Who is allowed to eat off of the kids' menu? Well, kids 12 and under. Let's use A to represent their ages. The ages of kids, now 12 and under. Well, let's see. If I'm 13, am I allowed to eat off of the kids' menu? The answer is no, I'm not. If I'm 11, can I eat off of the kids' menu? Yes. So that means ages less than 12 can eat off the kids' menu. Well, what if I'm exactly 12? Can I eat off of the kids' menu? Sure I can, because 12 and under. I have now written my inequality. I have a variable on the left and a number on the right and a proper inequality in the middle. Now it's time to graph. I draw myself a number line. I have to have two numbers, 0 and 12. I put a circle at the number. Then I ask myself, if I'm 12 years old, can I eat off the kids' menu? Is 12 less than or equal to 12? And the answer is yes. Then, where are numbers less than 12? Well, they go to the left. Now, technically, you can't eat off the kids' menu if you're under 0 years old. So, technically, we would stop it at 0. But for today and what we're learning, this is okay to leave it like that. Going on. Graph the solutions of each inequality on a number line. Remember, if it's only less than, like in example A, you do not fill in the circle. If it's less than or equal to, you do. If it's greater than, you do not fill in the circle. If it's greater than or equal to, then you do. Try the next 4. Pause the video and come on back to compare your answers. All right, so in letter A, y is less than 3. You start by putting a circle at 3. Then you ask yourself, is 3 less than 3? No, that means leave it not filled in. Leave it an open circle. Now, where are numbers that are less than 3? Well, they go to the left. They go to the left. In fact, many of you will start to notice that, do you see the arrowhead here and the sign here? That is always going to be the same. So if you need another way of seeing it or double checking, that's a good way to double check. The next problem. X is greater than -1. So I put a circle at -1. Then I ask myself, is -1 greater than -1? No, it's equal to. So I don't fill in the circle, leave it open. Then I need to draw or include numbers that are bigger than -1. Well, all numbers bigger than -1 are to the right. So I draw it with my arrowhead. Letter C, A is less than or equal to -2. So I put a circle at -2. Then I ask myself, is -2 less than or equal to -2? It is. Notice it has the equal to. Anytime it has that little line underneath, you will fill in the circle. Now, where are numbers less than or equal to -2? They are to the left. Letter D pays special attention to this one. We're going to put a star by it. I want you to put a note. Always have your variable first. Now, do you see that my variable is not first? So that means I need to switch it around. I want you to ask yourself, based on this sign, remember the alligator eats the bigger number. Which one is the bigger number? Is -6 bigger or is G bigger? Well, if your alligator sign is eating the bigger number, you can clearly see that G is bigger. Keep that in mind. When I want to switch this around, I want G first and I want -6 on the right. Now, I still need to show that G is the bigger number. So it actually changes my sign, doesn't it? Because the alligator needs to eat the bigger number, and then the equal to stays underneath. So always pay attention to which one is the bigger number, and make sure when you put your variable first that your sign is still indicating that that's the bigger number. Now go ahead and graph. Then graph. So I put my circle at -6. Numbers greater than or equal to -6 are my solution. So I need to fill that in. Notice it has the little equal to, so that was another giveaway. And greater than -6 goes to the right. So be very aware of those. Those will happen, and you need to be ready or prepared to solve those. All right, take a minute and graph these 4 with the video on pause, and then come on back to compare your answers. All right, so Z is less than -2. I put a 0 and a -2. -2 goes to the left. I put a circle at -2. From my circle, I do not fill it in because there's not an equal to, and I draw my arrow. Whoa, I drew it the wrong way. Less than -2 goes to the left. And again, notice less than, less than. The next one, I have a step to do before I can solve that one. I see that I need to have my variable first. And now when I look at my original sign, I see that the alligator eats the bigger number. Between the number 4 and the number T, I see that 4 is the bigger number. And so when I rewrite it, I need to show that 4 is greater. So T is less than 4. Now I'm ready to graph. I need to have a 0 and I need to have 4. I put a circle at 4, and numbers less than 4 go to the left. Letter C. I need to have a 0 and -5 on my number line. I put a circle at -5. Because it's equal to, I fill it in. Numbers greater than or equal to -5 go to the right. Again, notice this sign and the arrowhead. Notice this sign and the arrowhead. They match. Here's practice with another one that doesn't have the variable first. So let's rewrite it. Put C here, 2 here. Then ask yourself, the alligator eats the bigger number. Which is the bigger number according to the sign? The sign is showing me that 2 is bigger. So when I rewrite it, I need to indicate that 2 is still bigger with my sign. Now I'm ready to graph. So I put 2 numbers, 0 and 2. Put a circle at 2, I fill it in, and I show that numbers less than 2 go to the left. And again, as a double check, my arrowhead is going to the left. All right, now that is given an inequality, can you graph it? Well, what if I give you the number line and I ask you to write the inequality? Well, you can use any letter you want for your variable. So to make things simple, I'm just going to pick one. We'll use M for math today. M, now the number where the circle is my number. Now I have to decide on the sign. Well, I can see that my sign is greater than, because the numbers greater than 0 are being shaded in with my line. Then I ask myself, should I write the equal to underneath there? Well, this circle here is not filled in. So that would mean no, don't fill it in. And so M is greater than 0 is modeled on the number line. Take a look at B. This time I'm going to pick another random letter. I'm going to pick T. And then I look here where my circle is. It's at -1. Then I see that it's numbers that are less than -1. Again, notice how the arrowhead matches. Then ask yourself, should I fill it in? Is -1 one of the solutions? Well, -1 is one of the solutions because it's filled in. So t is less than or equal to -1. All right, next we have to talk about what if we graph more than one inequality on the same number line? We call those or inequalities and an inequalities. And really, it's just putting two graphs on the same number line. So it's no more difficult than what we were doing. Here's a real-world scenario where that might happen. A safe temperature for food is at or below 38 degrees or above 200 degrees. Represent a safe food temperatures on a number line. Here's my number line. Here's 0. In this case, I need to have two numbers. I do not care if they are properly a proper distance away from 0. Okay, so first, let's deal with this one. At or below 38 degrees. Think about this. Have you ever been to a potluck at family holidays or get-togethers, and people will leave food in the refrigerator all day long, and you have no problem pulling that food out and eating it? That's because it is kept at a temperature that is at or below 38 degrees. I can show that by filling in my circle and drawing a line to the left. Now, another way, you can be at your holiday dinner, they pull it out of the fridge, they put it in a crock pot, and they leave your meatballs or rice or whatever, casserole out on the counter all afternoon for snacks and munchies, and you have no problem going up there and eating it. Why is that? It's because they're keeping the food at a temperature that is at or above, in this case it says above 200 degrees. So above 200 does not mean equal to 200. It means above 200. And so that would be shown like this. Do you see that this is an or inequality? One inequality goes to the left, or the temperature can be stored at a temperature going to the right, but nothing in the middle. It has to be one or the other. Look at this and inequality. To go on a ride with a parent at Como Zoo, a child must be greater than 36 inches tall and less than 48 inches tall, because some of those are not meant for super tall kids. You guys are probably getting to the point where you've experienced this before, a lot of times in bouncy houses too. So if you need to be greater than 36 inches tall and less than 48 inches tall, we can graph the criteria for your height on the number line. Again, we're going to put 0 on there. We're also going to put the 36 on there and the 48 on there. Now let's start with graphing greater than 36. You have to meet both criteria in an and inequality. I have to be both taller than 36, which I can show like this, and I need to be less than 48, which I can show like that. So which heights meet both criteria? Well, only the heights that are between 36 and 48. So I'm going to erase anything outside of those amounts. So when I graph this, I'm going to change this to make the graph a little clearer. So greater than is not equal to. So greater than and less than 48 is not equal to. So I leave the circles not shaded in, and it's all heights between these two. Now, if you were 49 inches, could you go on the ride? Nope, you're too tall. But even though that's greater than 36, it's not also smaller than or shorter than 48. Likewise, if you were 35 inches, while that's less than 48, it's not also greater than 36, so you could not ride the ride. This is an and inequality. And inequalities is a situation where you must meet both criteria. Pause the video and try this. This is a speed limit sign. Graph the acceptable speed limits that you are allowed to travel on the highway if your speed limit maximum is 70 miles per hour and your minimum is 40 miles per hour. Hopefully you had a minute to try this by pausing the video. Then you should have a number line. It should look like this. Let's start by graphing the speed limit of less than 70 miles per hour. To show a speed that is less than 70 miles per hour or equal to, because I can drive exactly 70. So I'm going to fill that in. So I draw my line and I show less than 70. Then I need to show, a minimum of 40. That means my speed needs to be greater than or equal to 40. Not only do you have to be able to graph inequalities, we can write the inequalities based on the graph. I can see that the first two here are OR inequalities. You can tell an OR inequality because I've got one arrow going to the left and one going to the right. Notice they both look like that. I can tell an AND inequality because they are joining or coming together. So to write an inequality, you simply first focus on this one and write that inequality. Here, I've got x is less than or equal to -2. Then I write the word OR. Then I focus on this inequality. X is greater than 5. Let's try the next one. I'm going to focus on the first inequality. X is less than -2. X is greater than 5. And it's an OR inequality, so I write OR. And inequalities are the same way. Really, this one goes like this and is an arrow. So what is the name, or how would you write this inequality? X is greater than or equal to -2, and then I focus on the right-hand side, which really looks like this. X is less than or equal to 5. Let's do the other one, or the last one. Focusing on the left one first, there was a circle and a line going this way. So I'm just using x. Again, you could use any variable you wanted. X is greater than or equal to -2, and x is less than 5. And then now you're done. I want to show you one way that math people like to abbreviate or shorten and inequalities only. They like to combine it because, and share the x, so share the variable. They could write like this, x is less than or equal to 5. Notice this is exactly the same. And then they try to put the x in the same, or use the same x for the x is greater than or equal to -2. But again, look at this. Remember, the alligator eats the bigger number. X is bigger. And so show that x is bigger. So they could write this combined like this. And that only works for and inequalities. So really this x has been used twice, once going to the right and once going to the left. Okay, the next one, or the last one, let's see if we can switch that into shortened form. This one, I would have a -2 here and a 5 here, and x is in the middle. This one is exactly the same. X is less than 5. This one, I have to think for just a second, which one is bigger? X is the one that's bigger, so I show that it's bigger and keep the sign the same. So I now have that combined. And that's what that means. All right, I would like you to try writing these inequalities. Pause the video and come on back to compare your answers to mine. For number 1, x is greater than -8. I know that this is an and inequality because they're going towards each other. And x is less than 2. If you wrote it shared, which I would encourage you to try to get used to doing, I see that x is the bigger one. The x and -8, x is bigger. So I would write this like this. Also notice that these are exactly the same direction. That will always happen. So if you've noticed that pattern, I want to verify you're correct. That pattern will always exist, that the signs will face the same direction. Number 2, this is an OR inequality, so I cannot combine these. X is less than -2, or X is greater than 5. Number 3, X is greater than or equal to 1. Now this is an AND because they're going towards each other. X is less than or equal to 4. Combined, I always start writing this one first, and then I write the 1 here, and if you know that the signs are the same, it takes a lot of the guesswork out. But you can verify and should verify by looking at this sign and making sure that this is eating the bigger number. Number 4. Number 4 is also an AND inequality. X is greater than 3 and X is less than 7, or combined it would look like that. Number 5. X is an OR, so X is less than 2, or X is greater than 6, or inequalities again cannot be combined. All right, hopefully now you're getting the hang of this. Pause the video, try these 2. If you can successfully do these 2, you probably are pretty set for doing the homework, and you've probably mastered the learning target for today. So give these 2 a try by pausing the video, then come on back. All right, compare your answers to mine, and then your assignment is the 2-8 worksheet. So give that a try. Let me know if you have questions or come to a Google Meet.